Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss next problem on superposition theorem. You are given one circuit diagram with three sources, 4 volts voltage source and two current sources of 1 ampere and 3 ampere. The question is find the current in 1 ohm resistance. This is 1 ohm resistance through which we have to find out the current. Generally, they mention the current direction also whenever the question is to find current. In case that is not done, we can always assume the direction of current that we want. So let us assume downward current and let me call this current as I. So because we are discussing problems on superposition theorem, we are going to apply superposition theorem to find out the current through this 1 ohm resistance. We all know that in superposition theorem, we keep one source active at a time and find out the corresponding value of the variable. We do it for all the sources and at the end we have to add all the individual values that we have obtained. So in this case there are three sources. The very first step, I will keep 4 volts voltage source active and we will replace 1 ampere and 3 ampere current source. How do you replace a current source? Current source is always replaced by an open circuit. So let's start with step 1 and see what will be the equivalent circuit diagram to find current only for 4 volts voltage source. So that's your step number 1. I'm saying keeping 4 volts active. So keeping 4 volts active means the other sources must be replaced. Let us replace the two current sources with open circuit. So if I do that, if you do that, you can see both the current sources have been open circuited, removed from the circuit, and this is the equivalent circuit that we get. So now we find out the value of current I. I'm going to call it I1, and this I1 will represent the value of I only due to 4 volts. As you can see, because there is an open circuit on this side, this 3 ohm resistance will not carry any current because it does not have any closed path from the other end. So current in this branch is going to be 0. So there will be current flowing only in this particular loop. So you can see that I1, which is a current through 1 ohm resistance, will also flow through 2 ohm resistance because no part of I1 can flow through 3 ohm resistance as there is no closed path available beyond the other end of 3 ohm resistance. And for that reason, the current in this whole loop is nothing but I1. So if I simply apply KVL equation, so whatever mesh we have, let us apply KVL in that mesh. I'm going to travel in clockwise direction. The first voltage will be 4 volts as I'm going from negative to positive terminals of the battery. The second drop will be across 2 ohm resistance. I'm traveling in the direction of current, so drop will be negative minus 2 I1. The next drop will be across 1 ohm resistance. Again we will be traveling in the direction of current, so it will be minus 1 into I1 and this is equal to 0. So once you solve it, you get this will be 3 I1 equal to 4, and this gives us the value of I1. You can see I1 is going to be equal to nothing but 4 by 3, which will be 1.33 amperes. So that's the first value that we have got for I1. Likewise, now we find out the remaining two values of current I, this time due to the two current sources that we have in the circuit. So that's step 1. Let us now proceed to step number 2. So we consider the original circuit once again, and in step number 2, I'm going to keep 1 ampere current source active. So keeping 1 ampere active. So we will have to now replace 4 volt source and 3 ampere current source. We already know that to replace a voltage source, we have to replace it with a short circuit. So I'll just remove this 4 volts source and connect a short circuit in place of it. And how do you replace the current source? We all know that to replace the current source, we have to simply remove or make it open circuit in a given circuit. So this is my modified circuit diagram in which only 1 ampere is kept active and the remaining sources have been replaced. So the current through 1 ohm resistance in the downward direction that we have to find out, we will now call this current I2. I2 will be the value of the current only due to 1 ampere current source. Now let us find out I2. As I told you before, one can apply either mesh analysis or nodal analysis. Now in this case, you can see this particular mesh is open and hence there will not be any current flowing because there's an open circuit on this side. This is one mesh and this is one mesh. So there are two meshes in case we plan to apply mesh analysis. Also, because there's a current source in this particular mesh, you will directly get the value of the current in this particular mesh. So if I define current in this mesh as, let's say, IA, in that case we directly get the value of IA. IA is nothing but 1 ampere. So all I have to now do is write down KVL in this second mesh which is available. I will travel in the clockwise direction. Let us first travel through 2 ohm resistance. If I travel towards right, then I must define the equivalent current through 2 ohm resistance which is also flowing towards right. You can see current I2 is what will also flow in this particular mesh, because this mesh has resistance 1 ohm which is completely part of this mesh. This 1 ohm resistance is not being shared by the other mesh. Current in the adjacent mesh is 0, and hence the current in 1 ohm resistance, which is I2, will also be the mesh current in this particular case. So current through 2 ohm resistance will be I2 in right hand side direction, IA in left hand side direction. So if I want to define a current that is flowing towards right, it will be nothing but I2 minus IA. And because we are writing KVL traveling in the same direction, in the direction of current, the drop will be negative. So let me write KVL in second mesh. So KVL in mesh 2 will be minus 2 into I2 minus IA minus, now if I come down, I will write the drop across 1 ohm resistance. If I travel in the direction of current, the drop will be minus 1 into I2 equal to 0. Place IA with its value, which is of 1 ampere. So we get minus 2 I2 minus plus 2 IA. IA is equal to 1 minus I2 equal to 0. This gives me minus 3 I2 plus 2 equal to 0, and that means I2 is equal to 2 by 3, and 2 by 3 will be nothing but 0.667 amperes. So that's the second value of the current that we are looking for. This is the value with keeping 1 ampere current source active in the circuit. Now we have to go through one last step, in which case we will keep that third source, which is the second current source, active, and we will replace the other 2 sources like we have done in this particular case. So let's start with third and the last steps. In step 3, we will say keeping 3 ampere source active. So this current source will be removed, that means it is open circuited from the given circuit, and this voltage source will be replaced with short circuit. So this is a modified circuit we get, and the current that we define through 1 ohm resistance, I'm this time going to call it I3. So once again I can use similar analysis to find out the value of I3. Now, as we have been already doing, one can use either mesh analysis or nodal analysis to get I3. In this case, I3 is a current through this 1 ohm resistance which is being shared by both the meshes this time. So if I want to define current in this mesh, I cannot call it I3, I'll have to go for some different unknown. Current in this mesh is already known to be 3 amperes. So I can write mesh equation in this first loop. I can get the current in that loop. Along with 3 ampere, I can find the value of I3. Or one can also apply nodal analysis. In this case, this will be one node in the circuit, and this will be the second node which can be taken as the reference node. And if I do that, let us also mark the voltage at this node, call it Vx for example. Now if I want to apply nodal analysis, I'll have to write KCL at this particular node. Let me define 3 outgoing currents. These 2 outgoing currents I've defined. Current in this branch may not be defined to be outgoing because there's a current source, and current direction of this particular source is incoming to the node X. Hence let's not disturb that current direction, so I take it as an incoming current. So KCL at Vx will give sum of outgoing currents will be equal to incoming currents. The first outgoing current through 2 ohm resistance will be nothing but Vx by 2 because there is no other voltage source here. The second current in this vertical branch will be nothing but Vx by 1, and this will be equal to the current in this branch. Now please remember that you can't write current expression in this branch using 3 ohm resistance because this branch already has a current source, and hence we already know current in this particular branch. In KCL equation, all you need to know is current in each and every branch. So if there's a current source in a specific branch, then we already know the value of the current, something that is happening here. In such a case, one may ask that what is the contribution of this 3 ohm resistance? There is no contribution of this 3 ohm resistance in deciding how much current will flow in this branch because of this fixed value constant current source. And hence, any resistance that comes in series with current source will become redundant, or it will not affect the value of the current in that particular branch. So what is the incoming current in this branch? It is exactly equal to 3 amperes, or simply 3. So this will give me the value of Vx. It becomes Vx plus 2Vx equal to 6, and therefore 3Vx equal to 6 will give you Vx equal to 2. But we are looking for I3, but we are not very far. I3 current through this 1 ohm resistance, we are already written its expression in this KCL. It was nothing but Vx by 1, and hence I3 becomes 2 amperes. So basically we have got all the 3 current values, and now I'm in position to apply superposition theorem. So I'm going to say, using superposition theorem, capital I will be nothing but I1 plus I2 plus I3. So just taking all the values from the previous discussion, I1, I2 and I3. In the first case we had got it as 1.33, that was in downward direction, plus in the second case it was 1.667 plus, and in the third case we have got it as 2 amperes. If I add all the 3 values, I got the value of current, which becomes 4 amperes. I just mentioned the direction that I've assumed. The direction is downward. Please remember that you have to stick to the direction that you assume for I1, I2 and I3 also. You can't change the directions for I1, I2, I3 because ultimately you have to add the current only when they are flowing in the same direction. So we get the total current equal to 4 amperes using superposition theorem.